today's discussion, we're going to discuss about the progression. So, what is a progression? A progression, it is a process of developing or moving gradually towards a more advanced state. Then we have a sequence. Sequence is an ordered list of numbers that often follow a specific pattern or function. So, we have an example. For example, 2, 4, 6, and 8. It is a sequence with 4 elements, and the corresponding series will be 2 plus 4 plus 6 plus 8, where the sum of the series of the value of the series will be 20. There are various types of sequences and series, depending upon the set of the rules that are used to form the sequence and series. So we have different types of progression. First, we have arithmetic progression. Arithmetic progression is a sequence of numbers that follow a specific pattern. An arithmetic progression is a sequence where the differences between every two consecutive terms are the same. So this arithmetic sequence progression, it has a sequence of numbers in which each differs from the preceding by a constant quantity. So in arithmetic progression, we have formulas. First is the general formula for finding out n term of arithmetic progression series is t sub n is equals to a plus n minus 1 multiplied to d, where t sub n is equals to n term of arithmetic progression, a first term of arithmetic progression, n is the term we want to find, or from other available data we can find the value of n. Then d is the common difference between each successive term in arithmetic progression. Then the general formula for finding out the sum of first n term of arithmetic progression. So now we know the formula for finding out the n term of arithmetic progression. The next one is finding out the sum of first n term of arithmetic progression. So the formula will be S sub n is equals to n divided by 2, 2a plus n minus 1 multiplied to d, where S sub n is equals to sum of first n terms of arithmetic progression. Then a, the first term of arithmetic progression, n is the number of terms available in the series, and d is the common difference between each successive term in arithmetic progression. Then next is the general formula for finding out of first n term of arithmetic progression series if first and last term of series is already known. Then the formula will be S sub n is equals to n divided by 2 multiplied to a plus 1, where S sub n is equal to sum of first n terms of arithmetic progression. A is the first term of arithmetic progression, and n is the numbers of terms available in the series, and I is the last term of arithmetic progression. Next is the general formula for finding out the sum of first n natural number. So we have S sub n is equal to n divided by 2 multiplied to n plus 1. So Sn is equal to sum of first n terms of arithmetic progression, and n is the number of natural numbers up to which we want to find the sum. So since we know now the formula in finding out the n term of arithmetic progression, the finding out the sum of first n term of arithmetic progression, and finding out sum of first n term of arithmetic progression or series if first and last term of series is already known. And the last one is the formula for finding out the sum of first and natural number. So we will going to have an example in each of the formula so that we can further understand on how to do it. The first example is, the first formula is finding out the n term of arithmetic progression. So we have the first example, find out the 50 term for following arithmetic series 5, 8, 11, and 14. So for the formula in finding out the n term is t sub n is equals to a plus n minus 1 multiplied by d. So t sub 50 is equals to, our a is the first term, so we have 5. So a is the 5 plus our n is 50. So 50 minus 1, and the differences of each, or the common difference of each arithmetic series is 3. So 5 plus 50 minus 1 multiplied by 3 is 5 plus 49 multiplied by 3, and 49 times 3 is 147. So we have 5 plus 147 is 152. So our 50th term for the following arithmetic series 5, 8, 11, 14 is 152. For the next formula, in finding out the sum of first n term of arithmetic series. So we have, find out the sum of first 23 terms for following arithmetic series 3, 11, 19, 27. So as I've said earlier, the formula for finding out the first 23 terms for the following arithmetic series is S sub n equals to n over 2 times 2a plus n minus 1 times d. So here our n is 23. So S sub 23 is equals to 23 divided by 2 and multiplied by 2. So our a here is the 3. So the first term is 3 plus 23, our n, minus 1, and the common difference of our arithmetic series is 8. So 23 divided by 2, 23 times 2 times 3 equals to 6 plus 23 minus 1 is equals to 22, and bring that 8. Then 23 over 2 times 6 plus 22 times 8 plus 176. So 23 over 2 multiplied by 182 is equals to 23 times 91. Then 23 times 91 is equals to 2093. So the 23 terms for the following arithmetic series 3, 11, 19, 27 is 2093. Then the next example is find out the sum of first 50 terms for arithmetic series whose first term is 5 and the last term is 400. So next is the formula for finding out the sum of the first in term for arithmetic progression in which the first and the last term of the series is already known. So, for the formula is S sub n is equals to n divided by 2 and multiplied by a plus 1. So, our n here is 50. So, 50 divided by 2 times our first term is 5. 5 plus 400, the last term. So, S of 50 is equals to 50 divided by 2 is 25. 5 plus 400 equals to 405. So, 25 times 405 is 10,125. So, the 50 terms for arithmetic series whose first term is 5 and the last term is 400 is 10,125. Then the last example, find out the sum of first 60 natural numbers. So, for our formula for finding out the sum of the first n natural number is S sub n is equals to n divided by 2 and multiplied by n plus 1. So, our n here is 60. So, S sub 60 is equals to 60 divided by 2 times 60 plus 1. So, 60 divided by 2 is 30. 60 plus 1 equals to 61. So, 30 times 61 equals to 1,830. So, our first 60 natural numbers is 1,830. Now, since we've already done discussing about the arithmetic progression, we're going now to move to the next progression, the geometric progression. Geometric progression, it is a sequence in which each term after the first is a fixed number times the preceding term. The fixed number denoted by R is called the common ratio. So, the formula for geometric progression is, the formula for the n term is A sub n equals to A times R, or the common ratio, to the power of n minus 1. Where A sub n is the n term of the sequence and A is the first term of the sequence, R is the common ratio as I already said earlier. So, we will going to have a example. So, find the 10th term of the geometric progression 5, 10, 15, and so on. So, the formula for the n term is A sub n equals to A times R to the power of n minus 1. So, our n here is 10. So, A sub 10 is equals to, first term is 5. 5 times our common ratio is 2. So, 5 times 2 to the power of 10 minus 1. So, next step is A sub 10 is equals to 5 times 2 to the power of 9 is equals to 2,560. So, our 10th term of the geometric progression for 5, 10, 15 is 2,560. Now, we're going to moving on the harmonic sequence. A harmonic sequence is a sequence or progression formed by taking the reciprocals of an arithmetic progression. Equivalently, a sequence is a harmonic progression when each term is the harmonic mean of the neighboring terms. So, let's have an example. First is 1/4, 1/7, 1 over 10, 1 over 13, 1 over 16, and so on. So, the reciprocal of 4 is 1/4. The reciprocal of 7 is 1 over 7. For 10, 1 over 10, 13 is 1 over 13, and 16 is 1 over 16. So, evidently, it is an arithmetic progression with a common difference of 3. So, this one is a harmonic sequence. Next example. We have 3 over 5, 3 over 7, 1/3, 3 over 11, 3 over 13, and so on. So, the reciprocal for 5 over 3 is 3 over 5. 7 over 3 is 3 over 7. 9 over 3 is 1/3. 11 over 3 is 3 over 11. 13 over 3 is 3 over 13. In which their common difference is 2 over 3. So, this is an harmonic sequence. Then, the last example is 1/3, 1/10, 1/17, 1 over 24, 1 over 31, and so on. So, the reciprocal of 3 is 1/3. For 10, 1 over 10, 17, 1 over 17, 24, 1 over 24, and 31 is 1 over 31. So, the common difference of these examples is 7. So, it is also a harmonic sequence. So, that would be all my discussion for this progression. I am Jomairey Sunano, Bsed Mathematics 3.